we could use a capacitor by itself to keep an LED from turning off suddenly, but it would not last very long. So we added a PNP bipolar junction transistor, 2N3906, to extend that time. So to begin with, you can see we got the negative supply coming to the switch. When we close the switch, that charges the capacitor pretty quick. 10 microfarad capacitor, 100 ohm resistor, right there, charge path. Now also, we have a positive coming to the emitter of the PNP, and then base 10K resistor right there. So a current path. That turns the transistor on while we have the switch closed. When we open the switch, so that cuts power to ground there, but the capacitor has a stored charge. There's the negative side of the capacitor right there, positive to the left, and it makes its way back to the emitter of the PNP bipolar junction transistor in base. That little current path there, a small amount of current, allows a lot more current to go through the load. As the base current goes down, the load current will go down, the LED will fade off. So now, here's my circuit where we use a PNP bipolar junction transistor to take the stored charge of a capacitor and keep an LED on. So it's going to extend the time that a capacitor could do by itself. For this circuit, we have a switch on the low side here. We close it, comes to the negative side of the 100 microfarad capacitor through a 100 ohm resistor and charges it extremely quick. We also have this current path right here where the transistor will turn on fully, pretty much instantly right there. 10K resistor using the 2N3906, a PNP bipolar junction transistor. When I open the switch though, you can see that the capacitor, we got positive to positive, has a discharge path through the emitter to base, and that 10K resistor will set the timing. But in any case, it will discharge, and so just a little bit of current will allow a lot more current to go through the load. As current goes down though, finally the load current will go down as well. LED will fade off.